Welcome to chemistry class. We are in session 1 of the chapter chemical kinetics. In this session, first let me introduce to the meaning of chemical kinetics and then I'll make you to understand rate of reaction. First let me relate between thermodynamics and chemical kinetics. You know that thermodynamics deals with the feasibility of the chemical reaction. Isn't it? What's the meaning of feasibility? It means whether a chemical reaction can take place or does not take place. It is concerned only with the initial state and the final states of the reacting system and does not give any information about the various stages through which the reactants pass to reach the final state. Means it will not give any idea about the various intermediates formed when the reactants are converted into the products. Exactly speaking, thermodynamics does not give the information about three things. The first one is regarding the speed of the chemical reaction, means with what speed the reaction takes place, whether it is a fast reaction or slow reaction. So it will also not deal with the various factors on which the speed of a chemical reaction depends upon. And the third one, thermodynamics does not talk anything about the mechanism of the chemical reaction. So thermodynamics never talk about the speed of the chemical reaction. It will never deal with the factors on which the speed of a chemical reaction depends upon, and we have never learned even the mechanism of the chemical reaction in thermodynamics. So it will talk only about the initial state and the final state of the chemical process. Who will talk about all these three factors? And definitely it is nothing but chemical kinetics. And what is that chemical kinetics? Chemical kinetics is the branch of chemistry which deals with the study of the speeds of chemical reactions. The speed, or we exactly call it as the rate of chemical reaction, and also the factors affecting the rates of the reaction, and we shall also learn about the mechanism by which the reaction proceeds. So what are the three things which we learned in chemical kinetics? Yes, the first point is the speed of the chemical reaction. For a moment I use the word speed of the reaction instead of using rate of reaction. I shall discuss about the term rate of reaction later on in this session. And the second thing is the factors affecting the rates of the chemical reaction. The factors affecting the speed of the reaction. And the third one, even regarding the mechanism of the chemical reactions. First, let's understand what are the various types of chemical reactions. We know that different chemical reactions occur at different speed. Some will be slow and some will be fast, like that. So on the basis of the speed of the chemical reaction, they are broadly classified into three categories. So what are these three categories of chemical reactions? The first one is very fast reactions. The second one, very slow reactions. And the third one, moderately slow or moderately fast reactions. This is how the reactions are classified based on their speed. Let's discuss one after the other. This is the first one. Very fast reactions, or we also call them as instantaneous reactions. Means these are the reactions which are very fast and they occur as soon as the reactants are brought together. Means whenever we mix both the reactants, immediately the reaction takes place between those reactants. Generally, these reactions involve ionic species, and that is the reason why we can also call these reactions as ionic reactions. And these reactions take about 10 power minus 14 to 10 power minus 16 seconds for their completion. See, it is even less than a second. Means immediately once the two reactants are mixed, the reaction will be completed. So that's what they are called as very fast reactions or instantaneous, means immediately they start reacting with each other. And the best examples for this is when we mix an aqueous solution of silver nitrate with aqueous solution of sodium chloride, the precipitation of AgCl takes place with great speed. So here what happens is, here in aqueous solution, the silver nitrate, it exists as Ag plus and NO3 minus. And again in aqueous solution, sodium chloride exists as Na plus and Cl minus. So this Ag plus and Cl minus combines with very high speed, and that results in the formation of AgCl precipitate. We can take the other example like the neutralization of an acid with a base when their aqueous solutions are mixed. The best example, hydrochloric acid whenever mixed with sodium hydroxide, that results in the formation of sodium chloride and water. So these are some of the reactions which we call them as the instantaneous reactions. And the second type, they are very slow reactions. So these are the reactions which are extremely slow. They may take months together to show any measurable change at room temperature, and it is difficult to study the kinetics of such reactions as they are very slow. Difficult to study the kinetics of these reactions. Examples. The first example, the reaction between hydrogen and oxygen is very slow at room temperature. So whenever we take hydrogen and oxygen in a vessel, you keep it at room temperature. Even after 1 year, only 1% of the reactants will combine in order to form product under the normal room conditions. So that itself indicates that that reaction is very slow. When we take another example, reaction of atmospheric hydrogen sulfide on the basic lead carbonate, I can write it as even lead acetate. Here we know that the white paint contains the component lead acetate or the lead carbonate. So this lead acetate, whenever exposed to the atmospheric hydrogen sulfide, that white color component will be converted into the black color component. That is due to the formation of lead sulfide. That is how we can see in day-to-day life that on the white lead oil paintings, we can see some black patches here and there. That is only because of the formation of lead sulfide, because of the presence of hydrogen sulfide in the atmosphere. And another example, the reaction between carbon and oxygen at the room temperature in order to give carbon dioxide. Even after several years, they remain unreacted. So all these reactions are very slow. As these reactions are very slow, for very slow reactions and for very fast reactions, we cannot study the kinetics of these reactions. The third one, moderately slow reactions or moderately fast reactions, means these are the reactions which takes place at measurable speed, means whose rate can be calculated under the normal conditions. These reactions takes place at moderate speed and measurable rate at the room temperature. And one such example is the decomposition of hydrogen peroxide in order to give water and oxygen. Another example, the decomposition of nitrogen pentoxide in order to give nitrogen tetroxide and oxygen. Then a very common example, that is hydrolysis of ester. So when we take the common ester, ethyl acetate CH3COO-C2H5, this one on hydrolysis in presence of an acid or a base, here I took base, that results in the formation of sodium salt of acetic acid, that is sodium acetate and ethyl alcohol. So all these reactions takes place at measurable rates. So we can find out the rates of these reactions under the normal room temperature only. So that is about the various types of reactions based on the rate of the reaction or the speed of the reaction. Actually, what is the reason for studying this chemical kinetics? The first reason is to predict the rate of a particular reaction under the specified conditions. So here the conditions can be adjusted to make the reaction to go at a desired rate. So we will learn in future that some factors will influence the rate of reaction. So by altering those factors, we can make the reaction to occur very rapidly or slowly or with moderate speed. So based on the requirement, we can change the factors, and accordingly these principles are used in industry in order to get the maximum yield of industrial products. And the second one, in order to predict the mechanism of the reaction. What is the mechanism? Mechanism is nothing but the intelligent guess regarding the various elementary process responsible for the formation of the products from the reactants. So these reactants will never change into product in one step. It will take place in several stages. That one we call it as the elementary process, and all these stages together we call that one as mechanism of the reaction. These are the two main reasons why we are studying the chemical kinetics.